Foot, and I'd like to welcome everyone to today's webinar on migrating on-premises databases to Amazon RDS. We'll be uploading a copy of the presentation to SlideShare on YouTube tomorrow morning. All participants will be sent a follow-up email that includes a link that will allow you to download a copy. This month, we're going to take a look at the Amazon RDS Cloud Migration Lifecycle. Today's discussion will include the impact Amazon's cloud environment will have on your tech support operations, sizing a new environment and system cost calculations, recommended migration procedures, and an overview of Amazon's Schema conversion tool and database migration service products. By default, GoToWebinar mutes all participants except the speaker, which is a good thing because it reduces the chance of background noise affecting the presentation. We're going to hold questions until the end. There's a button on the GoToWebinar panel that will allow you to type your questions in. Kelly, who's the webinar's organizer, will bundle them up and we'll discuss them at the end. We want to be respectful of your time. We know that many of you will have meetings right after this one. I've timed the presentation to allow a Q&A at the end. Before in danger of running over, I'll respond to the remaining questions by email. In upcoming webinars, I'll be partnering with Corey Beck, a member of our Amazon Cloud Architecture team, to provide detailed information on supporting cloud databases in Amazon, both IaaS and RDS. We'll provide more detailed steps on provisioning your environments and also show you how to administer, secure, and monitor database management systems running in RDS. The challenge we all have with Amazon is it offers a huge, complex cloud computing environment. It's going to take a lot of subsequent webinars to cover it. We need to start somewhere, so consider this the first of many RDX Insight Series presentation on Amazon's cloud computing environment. I also distribute a monthly newsletter that you might be interested in. It covers a wide array of tech topics that we think would benefit readers both personally and professionally. You don't have to be a customer to receive it. This month's newsletter includes a video for a live migration for a SQL Server on-premises database to Azure SQL DB. In addition, the newsletter also contains articles on 2018's top cloud security threats, PostgreSQL, 2017's DBMS of the Year, and the globally consistent relational database, Google Cloud Spanner DB. If you'd like to be added to the distribution list, let me know. I'll display my email on the last slide of this presentation. You can always add me as your LinkedIn buddy. I write articles and SlideShare presentations on a lot of different wide-ranging technical topics. So let's get started with today's discussion. I'm not showing this slide as a cheap advertisement for our services. What I'm attempting to show is that RDX has experience monitoring and administering a wide range of environments. We support thousands of databases and operating systems. This includes Cloud IaaS, DBaas, on-premises, relational, NoSQL, commercial, and open source database products. One of the benefits RDX can provide all shops is our wide range of expertise. It's just the nature of our business. We support close to 600 customers, so we aren't constrained by any one organization's tech stack. We're required to administer virtually every database feature you can think of for every product we support, and we work with dozens and dozens of different tech stack combinations. RDX focuses on data infrastructure support services for databases, operating systems, and edge technologies. Because of the increasing interest in cloud services, especially migration, we separate cloud support from our on-premises services. We offer two different types of support contracts. Full outsourcing means we assume total ownership of your environment. We also offer supplemental support contracts. We augment the customer support teams. This allows our clients to fill critical support gaps for leading-edge technologies and product features. We support most IaaS offerings, which we all know is just a server in the cloud. We also support Azure SQL DB, Amazon RDS, and Oracle's Cloud DB platform. The cloud platforms that are garnering the most interest from our customers are from Microsoft and Amazon. Because of our large customer base and number of supported servers, we're a good bellwether for the adoption rate of different technologies and support strategies. We've created a robust set of white papers and webinars on our cloud migration services and case study success stories to market our services. You can find all of them on LinkedIn, YouTube, and SlideShare. Just do a search for RDX on those sites. Our most popular presentation is on supporting Cloud DB architectures. It's getting close to 2,000 views. RDX is positioning itself as the go-to vendor for cloud DBMS migration and support services. Our key value prop isn't just our expertise and experience in cloud migrations and support. It's also that we have experts in the source and target database platforms. SQL Server on-premises migration is to Azure SQL DB. MySQL on-premises migration is to Aurora or Amazon RDS MySQL. We have dedicated database product experts on both sides of the migration, source and target, which provides a huge value to the project. We'll help you migrate and support you once you're up there. Here's what RDX has learned over the last few years supporting cloud database management systems. They are certainly increasing in popularity. As they do, the requests for our services are also increasing. Cloud environments are architectures, not just database products. Depending on the vendor you choose, the complexity of these architectures and the way you administer them can range from very simple IaaS platforms to extremely complex multi-cloud DBAS environments. It's important for us to compare on-premises, IaaS, and DBS architectures to let us know what we're in for when we migrate our databases to Amazon's DBS platform. Since we're talking about database management systems, let's use the term, a well-used term, Database as a Service, or DBAS, to define that architecture. We all have experience with on-premises systems. We have to build the server rooms, provide heating, cooling, redundant connectivity, and power. We are required to install and administer all the mechanisms to provide the safest environment we can for our systems. We are then required to buy the server hardware, install and maintain it. When it breaks or we want to increase horsepower, we have to crack the chassis and work on the server components. We add CPU, memory, disk, whatever we need. When we perform these activities, we either have to take an outage or make plans to shift the system and workloads to another server to ensure availability. We also buy and administer the OS and DB software we need to run our database-driven applications. In addition, we evaluate, buy, install, and support all the other products we need: monitoring, security, auditing, third-party reporting products. We have to buy and support everything, both hardware and software. So let's move on to the cloud. Most IaaS and DBS environments are multi-tenant, which means we're sharing the vendor's compute and storage architecture with other customers. In addition, depending on the architecture and vendor chosen, the system will vary in degrees of scalability, elasticity, and administrative self-service. The architecture that is the closest to on-premises is infrastructure as a service. That's the architecture defined in the bottom left of this slide. With infrastructure as a service, the vendor provides the compute and storage infrastructure components and may offer some level of system maintenance activities. You have direct access to the server and storage, much like on-premises systems, but you're able to leverage a higher level of elasticity. Think of it as a server, more often than not, a virtual server in the cloud. You don't have to build your server support environment that provides air conditioning, light, multiple power providers, UPS systems, generators, and redundant connections to the internet. All that's provided by the vendor. But you will continue to maintain ownership of your software stack's administration, including the operating system and database. You install and administer your software of choice on that platform. So now we know that IaaS is just a server in the cloud. Let's move on to PaaS, or in our case, DBAS, Database as a Service. DBAS vendors provide all the server environmental benefits that their IaaS counterparts do, but DBAS significantly raises provider control over the customer's environment. DBAS providers assume ownership of the operating system and database software as well as the hardware. DBAS customers perform little to no operating system and database software administration. The vendors will be constantly enhancing their architecture's automation capabilities to further reduce the human labor required to administer their environments. The DBAS vendors also make modifications to their database software for two reasons. One is to ensure their product will work in their shared environment, and two, to leverage the benefits of the cloud and their architecture combined inherently provide. Geographic data redundancy would be an example. It allows customers to leverage the cloud to very easily create DR and HA systems. Each environment, on-premises, IaaS, and DBS, has strengths and weaknesses that are inherent to their architectures. I've provided this comparison information for all three architectures you can choose from: on-premises, IaaS, and DBAS. Each environment has benefits, drawbacks, and optimal use cases. Let's dig a little deeper into these. We've learned that IaaS is just a server in the cloud, so it's very close to on-premises systems. That means the learning curve is minimal, migrations will be easier, and you'll have less procedural and documentation changes required when compared to DBAS. With IaaS, you'll have more control over your environment, but it offers less automations, which means it'll be more labor-intensive than its DBAS counterpart. Because DBAS provides you with a pre-built environment and requires less manual labor, you'll also be able to take advantage of faster database-driven application time to market. You can just build them faster in DBAS. In an earlier slide, I stated that cloud environments are administered differently than on-premises systems. A mistake that some shops make is assuming that the DBAS vendors provide all the DBA functions for you. That would be an incorrect assumption. Migrating to a DBAS environment does reduce the amount of time a DBA spends administering the database environment, but it doesn't reduce that administrative time to zero. You will experience the most significant time savings in OS administration and hardware support. DBAs do spend time installing, patching, and upgrading the DBMS software, as well as monitoring, maintenance, setting up backup utilities. Many of these administrative tasks can be provided by the DBAS vendor, depending on the vendor and offering selected. But the majority of a DBA's time is spent working within the database systems themselves. They build schemas, grant security, assist developers with SQL and procedural program tuning, provide advice, enforce business logic using database features, tune database workloads, debug issues. DBAS vendors don't provide those services as part of their base package. It's important to remember that although the vendor may provide the mechanisms and processes to perform administrative activities, this does not reduce your support responsibilities for them to zero either. Personnel may need to configure how they're to be performed when they're scheduled. All the vendors provide patching, maintenance, utilities, backup processes, but it's up to the customer to review and customize them to meet their needs and then monitor their execution. The challenge is that all these offerings provide different computing architectures, cloud compute, memory, disk storage mechanisms. Your staff is going to need to learn how to use them. We'll get into some of these a little more deeply during the course of this discussion. Don't expect your personnel to become cloud experts overnight. You'll have to commit resources, then provide them with the time and training required to learn the Amazon architecture, provisioning, administering, tuning, securing, monitoring, backup recovery, disaster recovery. It's the same basic principles of good database administration applied to all DBMS systems. But in Amazon RDS, your administrators will be using different tools, utilities, and commands to perform those support operations. Here's a list of some of the changes that may occur when you move a database up into the cloud. Evaluating initial and ongoing costs is critical. We'll be digging a little more deeply into that subject. You aren't going to be purchasing your environment, you're going to be renting it. Those rental fees can vary pretty dramatically. Because the environment is different than on-premises systems, you'll have to update your change management processes and support documentation. How long that takes and the number of techs you'll have to dedicate to the project depends on, once again, the architecture you choose and how stringent your change management processes and documentation requirements are. You'll need to identify all the build, administration, monitoring, and access tools that your organization uses to interact with your on-premises databases. All shops usually have a couple of must-have products that are frequently used. The popularity of the cloud is driving most software vendors to make sure their offerings work with cloud systems, but you're going to need to double-check. In addition, Amazon provides close to 100 different products. You may be able to identify an Amazon product that provides like functionality. Our recommendation is to create a list and verify that those tools will continue to work with the cloud versions of the database. Depending on your overall cloud goals, size of your organization, you will need to consider the creation of new strategies and standards. I've included a laundry list of both on this slide. Since the cloud is a new architecture, it will affect all areas of IT and also impact how technology supports business ops. These aren't all simple decisions, and they will ultimately determine the success of your overall cloud strategy. Cloud strategies will have a very high visibility with executive management in any shop. The challenge is that the cloud is growing at a rapid pace with new architectures, vendors, products, and features being unveiled almost on a daily basis. The market landscape no longer consists of a handful of traditional on-premises relational database offerings. Those days are over. The market has exploded with dozens of new alternatives from organizations that range in spectrum and price points, architectures, storage models, and feature sets. The seemingly endless array of alternatives can easily become bewildering. The amount of documentation required that you're going to need to change is going to depend upon the breadth and depth of documentation your particular organization requires as a best practice. Larger shops traditionally have more documentation and procedures in place than smaller organizations. In addition, organizations that are governed by internal industry or governmental regulatory requirements are required to have more documentation and standardized administration procedures. So finally, we get to Amazon. So let's start talking about Amazon. Amazon currently offers a broad and deep suite of cloud DBMS services. Customers can choose from Amazon's fully managed database product offerings that include Relational, Aurora, NoSQL, DynamoDB, Data Warehouse, Redshift, and in-memory Elasticache. Amazon's RDS product suite provides consumers with 6 managed database engines that include Microsoft SQL Server, Oracle, MariaDB, MySQL, and PostgreSQL. Amazon also includes Aurora, their own relational database product, as a RDS offering. Aurora is a relational database that provides support for the MySQL and PostgreSQL database engines. We also learned that Amazon does offer incentives to convert to their database products. Amazon will allow you to use their database migration service for free for 6 months when you convert to Aurora, Redshift, or DynamoDB. You can extend that free service for an additional 3 months if you open up a support ticket with Amazon. You have to be aware of both database editions and database versions when you're migrating to Amazon. Here's a quick example. Although Amazon does offer license-included options for all SQL Server editions, Express, Web, Standard, and Enterprise, it only offers the license-included option for Oracle's Standard Edition products. If you want to use other editions of Oracle, like the Enterprise version, you're going to have to choose the Bring Your Own License option when you configure your Amazon RDS instance. You can also choose the BYOL option for other databases. You need to check the Amazon documentation for your database to determine what licensing options are available. In addition, it's also important to verify what versions of the database product Amazon supports. Let's use MySQL as an example. Amazon supports the MySQL Community Edition versions 5.5, 5.6, and 5.7. You have to check that. I've included a link at the bottom of this slide to an Amazon page that contains links to editions and versions supported, as well as the licensing options available for each RDS product. And all participants are going to get a copy of the slides, and they'll be able to view the webinar video. Amazon currently has an enormous lead over both Microsoft and Oracle in cloud customers and cloud revenue. In addition, since it has a head start on its competitors, it has built a very robust cloud service architecture, and Amazon has the funds and expertise to constantly expand into new offerings and improve upon existing ones. The vendor is able to leverage its cloud computing architecture to provide a robust DBAS environment. We covered the general high-level benefits of DBAS in earlier slides. We're not going to restate them now. As we'll learn in a few minutes, customers are able to choose from a wide range of database products, editions, versions, licensing, and payment options, as well as memory, CPU, I/O, and disk configurations. We're going to learn all about those in upcoming slides. The vendor provides a very strong set of administration and monitoring tools. You can use the AWS Management Console, the AWS RDS Command Line Interface, called the CLI, or API calls to access, build, and administer the database environment. You can also choose from several monitoring tools. You can subscribe to RDS events, view your database log files, and activate RDS Enhanced Monitoring to gather additional metrics. RDS integrates with Amazon's Global CloudWatch monitoring tool. You can use CloudWatch to track metrics, monitor log files, and set thresholds and alarms. One of the options you can use to secure your data is Amazon's Virtual Private Cloud. Amazon VPC lets you provision systems in a logically isolated section of the AWS cloud. You're able to select your own IP address range, create subnets, configure route tables, and network gateways. You can create a public-facing subnet for your web servers that has internet access and place your databases and app servers in a private-facing subnet with no internet access. You can also create a hardware VPN connection between your data center and your VPC, which allows the AWS cloud to be viewed as an extension of your internal network. You can encrypt your Amazon RDS instances. Now we're talking about security. So you can encrypt your instances and snapshots at rest by enabling the encryption option for your RDS DB instance. Data that is encrypted at rest includes the DB instance data, its automated backups, read replicas, and snapshots. As I stated earlier, the challenge with Amazon is that there are so many important topics for us to learn. The goal of this presentation is to provide a high-level overview of Amazon and highlight some of the recommended methods you can use to migrate your on-premises DB systems to their DBAS environment. The Amazon cloud consists of 18 worldwide geographic regions. That number is always growing. Regions are then broken down into availability zones. When you review the regions during your configuration, you're going to find that each region usually has 2 or 3 availability zones. An availability zone is a data center that has all the environmental resources required to ensure it's highly available. The data centers are in different geographic regions with enough distance between them to ensure both data centers aren't affected by most, and that's the key word, most unfortunate events. You're going to want to go to different regions for DR. Traditionally, customers choose regions that are in close proximity to their user population. Availability zones in a region are connected through low latency links, which allow customers to configure HA architectures with quick failover capabilities and no performance degradation when the system is running from the standby environment. You'll need to verify that all the products you want to use are available in the region you're selecting. RDS, last time I checked, is available in all regions. But if you're going to use other Amazon products and you want to keep everything in the same region, you're going to want to make sure that that region provides support for all of your selected products. DB instances are configured to run in a region's availability zone. When you configure a multi-AZ environment to provide HA, you are creating a primary instance in one availability zone and a standby in a second availability zone. Using multi-AZ implementations isn't a requirement, but of course it's highly recommended. When you configure multi-AZ, Amazon builds the backend environment for you, including setting up replication. It's important to note that you can't replicate across regions. You can only replicate to an availability zone in the same region. Multi-AZ is an HA failover, it's not DR. During DB instance provisioning, you'll choose the database product, edition, licensing, VPC, multi-AZ, and backup retention options, to name a few of them. The initial setup is pretty simple. You will also allocate CPU, memory, disk storage, and I/O to the instance. We'll describe those configuration options in upcoming slides. Customers can also leverage MySQL, MariaDB, and PostgreSQL read replicas. These features are provided by the database product, not Amazon. Read replicas aren't recommended for use as HA failovers because there could be latency issues. The read replica, because of several factors, could be behind the primary database. You use multi-AZ for high availability and read replicas to distribute read access to other systems. The benefit that read replicas provide is that you configure them to replicate data to another region. Multi-AZ requires that you replicate data within a region. Evaluating initial and ongoing costs is critical. Once again, you're not purchasing an environment, you'll be renting it. Those rental fees can vary pretty dramatically. You can search the web and find numerous cases of shops that didn't do their due diligence when they configured their cloud system and were surprised at the charges they were incurring. That's not the vendor's fault. It's the customer's responsibility to fully understand each vendor's cost calculations. There are numerous articles that provide best practices on what you can do to reduce ongoing costs. So let's take a look at some of the factors used to generate the RDS instances costs. This is an important part of the discussion. You can choose to pay on demand or reserve an instance for a 1-year or a 3-year term. Of course, you're going to incur the highest rental fees if you choose on demand. The longer the term you choose and the more money you pay up front, the lower your instance's hourly cost will be. You can also choose to include a license in your rental fee or bring your own. Database additions will also impact your hourly costs. It's obvious you'll pay more for SQL Server Enterprise than you would for the Express Edition. You'll then need to size your instance, how much CPU, memory, and network performance you want to reserve. Amazon provides a table in their documentation that you can use to determine the configuration you need to appropriately size your Amazon instance. I've provided a link and a lot of other links to documentation in an upcoming slide. So let's talk about this information on the right. The configuration for the example I use on this slide is for a db.m4.10x large instance. The letter M, that's this one. So we're going to go from left to right. The letter M, it indicates that this is a standard class instance, not memory optimized. Amazon recommends configuring RDS databases to use memory optimized, which is the R option. The number 4 indicates that this is a current gen instance. The higher the number, the later the generation. 10x large would be 10 virtual CPUs. The ECU rating to compare against other selections would be 124.5. You can use this instance in a virtual private cloud. The instance can be configured to use EBS. The maximum bandwidth is 4,000 megabits per second, and the network performance rating to compare against other selections is high. Amazon offers a lot of instance performance configurations to choose from. As I said previously, Amazon provides detailed descriptions for all instance performance configurations. It's a pretty simple process to scan that table to select the performance configuration that best meets your needs. In addition, once you're up and running, you have the capability to modify your instance class, but it's going to require an outage. You can choose to make the instance class change immediately, or we can schedule it to occur during your next maintenance window. You also have a couple of disk storage options to choose from. This is also important. Before we begin, a couple of definitions and explanations are in order. You'll quickly notice that Amazon often uses KIB, MEB, GIB, and TEB to define storage and throughput. Well, most of us are used to the kilobytes, megabytes, gigabytes, and terabytes units of measure. If you Google the term GIB to gig, a calculator will pop up. Here's a few examples to put you at rest. 1 MEB equals 1.04858 megs. 1 gigabyte equals 1.07374 gigabytes. 1 terabyte equals 1.09951 terabytes. Most of us know what IOPS are. They're a unit of measure representing I/O operations per second. And that's the key, I/O operations per second. And they're measured in Amazon in KIB, K-I-B. The underlying drive technology determines the maximum amount of data that a volume type counts as a single I/O. When small I/O operations are physically contiguous, Amazon EBS attempts to merge them into a single I/O up to the maximum size. When you create your RDS instance, you can choose from general purpose or provisioned IOPS storage. Let's talk about general purpose first. General purpose volumes, they deliver single-digit millisecond latencies and the ability to burst to 3,000 IOPS for extended periods of time. I'll show you how they do that in a couple seconds. Baseline performance for these volumes is determined by the volume's size. Amazon states the baseline is 3 IOPS per gig. The larger the amount of disk you allocate to the instance, the more IOPS you get. Well, more IOPS, better performance. Here's the example that Amazon uses. Baseline performance for a 100 gig volume is 300 IOPS, while a 1 TIB volume would be 3,000 IOPS. Volumes that are smaller than a TIB can still provide you with adequate performance. Here's why. That's because Amazon provides a reserve burst balance of 3,000 IOPS, which they describe as a burst bucket. That's a good way to describe it. When you create your instance, Amazon gives you 5.4 million I/O credits in your burst bucket. That gives you 3,000 IOPS for a 30-minute burst. When data access activities are low, you add I/O credits to your burst bucket. When you begin to exceed baseline performance, you use those credits up. When you run out, you're back to baseline performance. You need to remember that this is just for volumes under a TIB. Amazon also provides metrics to monitor your burst bucket. This is a must-monitor set of metrics that you will need to evaluate regularly if you're going to use general-purpose volumes. Provisioned IOPS storage is better for I/O-intensive workloads, like databases. You specify the amount of storage you want, and then select the amount of dedicated IOPS you want to allocate to that storage. You need to remember with provisioned IOPS, it's a use it or lose it setting, month by month. You can't roll over unused IOPS. You can choose from 1,000 to 40,000 provisioned IOPS for your database instance. The challenge we all have is trying to calculate the amount of IOPS we're going to need. You'll need to work with your friendly OS and network admins to measure your on-premises environments, and Amazon provides recommendations and calculations in their DB product-specific and general disk storage documentation. After you select your initial configuration, RDX's recommendation is to use Amazon's CloudWatch software often to monitor IOPS utilization. I have an entire slide that provides all the links you'll need to learn more about the Amazon architecture, provisioning, monitoring, and cost estimations. Amazon provides details on data transfers at the bottom of every RDS DB products pricing page. This is also important. Some of the data transfers are free and some aren't. Most of the fees seem fair, but if you're going to be transferring a lot of data, you'll need to factor those costs into your estimation. Here's an example of important costing information provided on each RDS products pricing page. At the bottom of the SQL Service pricing page, you're going to find these two notes. The first note states that data transferred between availability zones for replication of multi-AZ deployments is free. That's nice. The second note states that a DB snapshot copy is charged for the data transferred to copy the snapshot data to another region, like for DR. Once the snapshot is copied, standard database snapshot storage charges will apply to store it in the destination region. You must read the RDS products pricing page thoroughly. Amazon provides a cost calculator that you can use to estimate your monthly charges before you provision your RDS instance. The link to it is provided on the next slide. Here's the display. If you have one takeaway from this presentation, it should be to use the cost calculator to perform what-if scenarios. Select on demand and reserve payment options, different regions, instance classes, and disk allocations. Choose standard and provisioned IOPS disk configurations. Configure a multi-AZ architecture. Read the information provided by the help pop-up bubbles. Every time you make a change, the cost calculator at the top will show you an estimate of what your monthly charge will be. This what-if testing will help you to customize your Amazon RDS instance environment to meet your needs. Here's the page containing all the links I've been referring to throughout the course of this presentation. I have links to the RDS product pricing pages, instance class definitions, and the different types of storage offered by Amazon. I provide a link to the IOPS monitoring, as well as how to configure VPC and multi-AZ options. The FAQs are also very helpful. After you migrate, one of your top priorities, in addition to making sure everything is working fine, is to monitor resource consumption. If you don't, you may end up with a budgetary surprise or two. There are a lot of different instance class and disk option combinations you can choose from. The instance class and disk storage you select, as well as how you configure them, will impact your monthly fees. Of course, our recommendation, do the background work to understand them. Choose the settings that best fit for the environment when you build. Then monitor your fees regularly and adjust as necessary. We all know that can take only a few improperly tuned queries added to the system to impact the resource utilization of any environment, on-premises or the cloud. The challenge with cloud environments is that any spikes in workloads will impact resource utilization and possibly the instance class and IOPS you chose during your initial configuration. Once again, you're renting the cloud environment and you're being charged by Amazon based on resource consumption. We then need to select databases to be migrated to Amazon RDS. Some databases just work better in the cloud than others. One of the challenges that we need to evaluate exactly is how much data do you need to transfer back and forth in that architecture? How much data and how long does it take to send and receive it? In addition, we need to determine how much Amazon charges us for those transfers. Does the database interact with other systems? A popular feature in any DBMS is using its inherent linking capability to access data in other systems. You can use a single SQL statement to access one database and then use links to join that information to data residing in other databases. Will those other databases be on-premises or will they also be in the cloud? Does it generate a lot of output? Do you use that database data to refresh other systems? Does it generate large reports or flat files and other data streams that are used as input to other apps? What features does the database use? We'll need to verify that all the features utilized in the on-premises databases are available in Amazon RDS. If you use a particular feature that's not available or Amazon provides like functionality, you will need to determine how big of an impact that will be. We will also need to analyze all the software that interacts with the database: application software, utilities, monitoring, security. Does the database utilize any highly available features? What are its backup requirements? How many copies of your backups do you need to retain? How big is it? How will you initially seed the database? Do you want to use the database products data transfer capabilities or Amazon's? Security. Is the database governed by internal industry-specific or governmental regulations? We learned that DBS environments don't have the same level of visibility as IIS or on-premises. You also need to estimate the processing workloads. You're going to be renting that environment, and Amazon's going to charge you based on CPU, memory, I/O, and disk storage. Are your workloads fairly predictable, or do they have large fluctuations? We need to estimate how much work it's going to be to migrate that database to the cloud. Your options can range from lift and shift with minimal changes to a total application rewrite. You may have outdated apps that you want to rewrite from scratch. What we need to remember is that no database is an island. As I said, they take feeds from flat files and other database applications and produce output that is ingested by other apps and end users. Getting a lot of data into and out of a cloud DB system can be challenging, especially if there are tight time constraints and large data volumes need to be transferred. We've had several customers find that the different cloud offerings don't support the exact same features as their on-premises counterparts. What we found was that the different flavors, Oracle MySQL versus Amazon Aurora MySQL, didn't work the same way for some features, or the features weren't available. Let's take a look at the next slide. We're going to compare SQL Server on-premises to Microsoft SQL Server on Amazon RDS. I'm not going to go into each and every one of these, but here's the tech differences between Amazon SQL Server RDS and SQL Server on-premises. The features listed on this page do not exist in Amazon. If you currently use SQL Server on-premises, you're going to need to be aware of these differences before you begin migrating databases to the cloud or creating new DB systems in Amazon. In addition to these unsupported features, Amazon RDS doesn't support the following security roles, which causes a lot of SQL Server DBAs issues during the conversion: bulk admin, DB creator, disk admin, security admin, server admin, sysadmin. Also doesn't support SSIS, AS, or RS. You'll find a list of features supported and not supported in Amazon's product-specific documentation. I'm not stating that these environments aren't effective as on-premises. They have different features, and we all need to be aware of those differences. Some of the feature mismatches are complex, and it can be a challenge to leverage the like functionality provided by Amazon. DBAs and developers are often required to work together to come up with a viable solution. This feature mismatch isn't just an Amazon issue. Take a look at Microsoft's Azure SQL DB documentation. It provides a list of differences between SQL Server on-premises and Azure SQL DB, two database products built and offered by the same vendor, and they have feature mismatches. Now that we've selected our database or databases for migration, let's take a look at the high-level steps we will perform. Planning for a cloud migration is like any other tech project that's complex and has a lot of steps. You will need to dedicate time to educate your team in the cloud target you've chosen. You'll want to become familiar with how the data is stored, how your applications will connect to the cloud database, how it would be administered, monitored, secured, audited, and backed up. Does your team know how to recover the system? Will you be implementing multi-AZ architectures? Are there any feature mismatches that you'll need to plan for? How will you transfer data back and forth to the cloud during daily database operations? Can your network and cloud connection handle the increased volume? You also need to determine if you want to migrate the database to the cloud in one step, or you want to seed it and then keep it in sync until you perform the final production cutover. Some of these steps I'm showing may be combined or be removed entirely. Depending on the mechanism you choose, you can migrate the database structure and the data at the same time. You may choose to migrate the database data and cut over after you verify it's been successfully moved to the cloud without setting up synchronization. What steps will you perform to verify that the database has been successfully migrated to the cloud target? At the end of the planning phase, you should also be able to more accurately estimate the level of effort required to migrate the database and the rental fees incurred once you're up there. Your project document will include the mechanisms you've chosen to upload the database to the cloud. In addition, it will document the steps you will execute to perform the migration and verify that the process has completed successfully. As I stated when I started discussing this slide, cloud migrations are much like any other tech project. Robust testing and verification will be critical components of your project plan. All the leading cloud database providers, including Amazon, want to make it absolutely as easy as possible to migrate your on-premises databases to their architectures. There are several strategies and mechanisms you can use to initially seed the cloud database with your on-premises data, and then keep the systems in sync until you're ready to perform the production cutover. We'll discuss those mechanisms as well as cloud migration strategies and best practices in upcoming slides. The mechanisms you choose to migrate the system will depend on several key factors. The target platform and product. Will you be switching database products during your cloud conversion? The transfer, conversion, and synchronization tools provided by your cloud vendor, in this case, Amazon. How much data will you be migrating? And the acceptable outage length. Can that system be down? If so, how long? RDS has performed a fairly high number of migrations from on-premises to IaaS and DBS environments. Most of these projects have not required us to switch to a different DB product during the cloud migration. We usually switch products on-premises, then migrate. As a result, we don't have a lot of experience converting databases to different products during migration, the migration process itself to Amazon RDS. RDS DBAs review the amount of data being transferred and the application's uptime requirements. Based on those combination of factors, we chose to either transfer the data and perform the production cutover after verification was complete, or initially seed the database with data and then use synchronization tools to keep the cloud database in sync until the production cutover was performed. If you don't intend to switch products during your migration to Amazon, you might be able to use the product's inherent features to perform the cloud conversion. Amazon provides a list of migration options available for each RDS product. Look for the section titled Importing Data Into in Amazon's product-specific documentation. Some may be viable options, others won't be. Amazon is making, once again, every effort to accelerate the wholesale adoption of their cloud DBMS systems. The vendor provides utilities that help customers migrate their on-premises environments to their cloud systems. In Q4 2016, Amazon released the AWS Database Migration Service, DMS. DMS is a very robust replication utility that allows you to initially seed your Amazon cloud database with data and then keep it in sync with your on-premises system. The replication utility allows you to migrate larger systems to Amazon and also provides shops with the ability to maintain cloud on-premises hybrid architectures. Not only does the product provide replication between homogeneous sources and targets, Oracle on-premises to Amazon Oracle IS, for example, but it also allows you to set up replication between heterogeneous platforms, Oracle to Aurora, SQL Server to MySQL. We're going to talk about their second tool. Amazon also provides the AWS Schema Conversion Tool, SCT. Amazon states that SCT can automatically convert the source database schema, including views, stored procedures, and functions, to its Amazon counterparts. The product also allows you to scan application source code for embedded SQL statements and convert them to access the new database product. I love the phrase they use when they describe their conversion utility. SCT optimizes the code by converting legacy Oracle and SQL Server to Amazon, helping you modernize your applications. We know that homogeneous database migrations to Amazon RDS will be much simpler than switching to a different database product at the same time. The big challenge you face with homogeneous conversions is making sure you transfer all of your data to the cloud system. It's a much more daunting task to migrate your data to Amazon RDS and convert to a different database product at the same time. SCT is a standalone application that is available for Fedora, macOS, Microsoft Windows, and Ubuntu. SCT only runs on 64-bit, and it installs the Java runtime environment. You download and run the install files, then install the drivers you need to access your on-premises database source. The AWS Schema Conversion Tool helps you with heterogeneous database migrations by converting the source database schema and many of the database objects, including views, stored procedures, and functions, to a format compatible with the target database. During this process, SCT performs cloud-native code optimization by converting, another example, Oracle and SQL Server functions to their equivalent AWS service. You select the objects you want to convert, hit the big convert button, and SCT converts the schema. SCT provides you with the ability to review and edit the converted DDL. You perform the same operations to convert your application SQL code. The source databases are the traditional relational vendors: Oracle, SQL Server, Teradata, MySQL, PostgreSQL, and the targets, of course, are the DBMS products on Amazon RDS. The products in the left column can be converted to the products in the right column. Amazon also allows you to use SCT to convert your schema from Aurora to PostgreSQL RDS. Conversion issues will be dependent on your source and target database. Some database products will be easier to switch to a different product than others. It's obvious that the number of objects you're attempting to convert will contribute to the number of issues. More objects converted equals more potential for issues. The types of objects and their complexity will also have an impact on the number of conversion issues you'll have to contend with. RDX recommends that you run the Schema Conversion Tool conversion reports for both your schema and application SQL before you begin the conversion process. The reports will let you know what issues you're going to face. For schema objects that can't be automatically converted to the target database engine, the summary includes an estimate on the level of manual effort required to create schema items in your target DB instance that are equivalent to those in your source. The report groups the manual conversion activities into the following categories. Simple, actions that can be completed in less than 1 hour. Medium, actions that are more complex and can be completed in 1 to 4 hours. Significant, these are the heavy hitters. Actions that are very complex and take more than 4 hours to complete. SCT also provides recommendations to resolve conversion issues for both schema and application SQL conversions. Now we're going to talk about the database migration service in the next slide. It works with data. The database migration service, DMS, also provides a similar type of report. Since it works with data, a DMS assessment report includes a summary that lists the unsupported data types and the column count for each one. It includes a list of data structures in JSON for each unsupported data type. There are 2 levels of unsupported data types. Data types that are shown in the report as not supported and can't be migrated. The second set are data types that show in the report as partially supported, and you're going to have to watch because they might be converted to another data type during the conversion. Let's talk about Amazon's database migration service. Amazon DMS allows you to migrate, convert, and synchronize data to both IES and DBS targets. You can also use the utility to migrate to the cloud and convert to a different database product at the same time. There's a bunch of source target combinations to choose from. They can be heterogeneous or homogeneous targets. You have to rent DMS from Amazon, but you can use DMS for free if you're going to migrate to Aurora, Redshift, or DynamoDB. At a high level, the steps to use a DMS are, and it's pretty simple. You create the replication server. It's just an instance that runs on Amazon EC2. You then create source and target endpoints that contain the connection information about your data stores. The last step is to configure one or more tasks to migrate the data between the source and target data stores. That task consists of 3 phases. A full load of existing data to the target. Once that process is complete, DMS applies all the cache changes captured during the full load. It then activates ongoing replication. You can monitor the progress and resource utilization of your task using Amazon CloudWatch, the AWS Management Console, the CLI, or the AWS DMS API. Any of the sources on the left can be migrated to any of the targets on the right. As you can see, there are a lot of data conversion options to choose from. Just like its SCT counterpart, all issues that occur in DMS are logged. The product will provide recommendations to resolve the problem. Amazon's documentation on SCT and DMS is extensive and includes robust troubleshooting sections. We need to remember that DMS's primary focus is on data migrations. In some cases, DMS can create schema objects during the data migration, but it won't convert schema objects to a different product. That's what you use SCT for. DMS will create tables, primary keys, and in some cases, unique indexes. That's because those objects are required to migrate the data. DMS won't create any other objects that are not required to migrate the data from the source. For example, it doesn't create secondary indexes, non-primary key constraints, or data defaults. You'll have to create those objects manually. If you intend to migrate a large amount of data to Amazon, you do have the option to use Amazon Snowball in conjunction with DMS. There's a section in the documentation that provides you with all the information you need to migrate large amounts of data from your on-premises systems to Amazon RDS. If you take the time to perform the required due diligence and be willing to absorb the costs associated with the upfront analysis, you will be able to create an Amazon environment that meets your application's processing requirements. If you don't, you may end up spending more time performing migration than you expected, and the production cutover may not be as smooth as you wanted. You may also undersize your environment, which could result in performance problems. If you oversize, you'll be paying too much. The cloud in some cases may not save you money when compared to on-premises, but it does provide you with increased agility, ability to scale, and you'll be able to leverage the inherent benefits that cloud architectures provide. The more analysis you perform up front and the more you learn about your new target environment, the less problems you'll have during the actual migration and cutover. Just like every IT project we all work on in this profession. RDX doesn't profess to be an expert in all things cloud. The benefits we provide is that we have a large customer base and many of our clients use cloud database systems. We are, above all, a learning organization, and our collective egos don't prevent us from saying that we teach, but we also learn from our customers. We have customers that range from bleeding edge, latest technology, to those that have a strategy of yesterday's technology tomorrow. That range of strategies allows us to learn many different ways of doing things, how not to do things, and the pros and cons of many different architectures and tech stack combinations. This wraps up our presentation. Just a quick note to mark your calendars for RDX's next Insight Series presentation. On Thursday, June 21st, Jim Donahoe and I will be presenting Azure SQL Managed Instances. Microsoft is stating that managed instances will allow shops to lift and shift SQL Server on-premises databases to Azure DBS with minimal to no changes. You can continue to use instance-level capabilities without changing your application design. You can always send me an email. It's in the upper right of this slide to join our newsletter. You don't have to be a customer to receive it. So Kelly, are you there?
Yes, I am here, Chris, and we did have a couple questions come in during the presentation. So I'll begin with this one. It reads, what part of the conversion process is the most challenging to shops migrating to Amazon RDS?
Okay, that's a good one. There's several challenges. Number one is underestimating the impact the new architecture will have on their organization. That's the reason I included several slides on the cloud's impact in this presentation, and I've dedicated an entire webinar to that topic. You can go to RDX's YouTube channel and view the webinar. You can also download the PowerPoint slides from SlideShare. We all need to remember that these cloud systems are new architectures, not just products. The second issue is identifying compatibility issues too late in the migration process. They find out their application uses a feature that's not supported by the DBaas product. One of the first steps that must be performed is to review the cloud vendor's documentation to determine what features are or are not supported. Any other questions?
Yes, we had one more. Do you have any general recommendations to ensure our cloud migration is as trouble-free as possible?
Yes, don't go it alone. Bring in resources that have conversion experience to jumpstart the process. Hire in-house, leverage consultants that have been there, done that. Talk to us, RDX. This isn't a plug for our services, but we've migrated a lot of DBs to the cloud and can help you with the entire cloud lifecycle. We've got our lumps along the way, from initial strategy design to production cutover. We know what works and what doesn't, what you have to watch out for. That's the rest of the questions, Kelly?
That's it.
Okay. I'd like to thank everyone for attending today's presentation and look forward to seeing you in our next month's presentation on managed instances. Thank you very much, everybody. Bye-bye now.
Thank you.